Hi, this is Hayden Gaspard with Acclaim, and today I'm going to be discussing the topic of distributed generation. It's an exciting technology, and while it's not necessarily new, it is still a bit of an unknown to a lot of businesses and government entities and medical facilities that could make it a useful piece of their energy portfolio. So what is distributed generation? In short, it's just a way to utilize your emergency generator's ability to put electricity back onto the grid. You do that through what's called a paralleling switchgear, which we'll touch on later, but simply it's just a switchgear that allows you to either supply your facility with power that the generator produces or to send it back to the utility grid, or to do both at the same time. So why would you want to do that? Well, there's a few reasons. Number one, it generates revenue. So this depends on your state and your region, but utility and system operators design programs for emergencies that call on customers to either curtail their load and sometimes to inject load back onto the grid. So in Texas here in ERCOT, we have what's called the Emergency Response Service, ERS. So when operating reserves for the state get low, they'll call on ERS participants to curtail their load or to run generators to put more load on the grid. You also in Houston have the CenterPoint Load Management Program, very similar, does the same thing, just specifically during the summer for the Houston region. So they have different names depending on where you are, but commonly these are just referred to as demand response programs. And the good thing about demand response programs, almost always they pay you just to be available. So regardless of an emergency event is called or not, if you're an ERS participant or a CenterPoint Load Management or whatever demand response program you're in, you'll get paid just for signing up for it. Now, of course, you have to pass tests. They'll run a random test to make sure that you actually are available to curtail. But in the event that you can do that, with which you should be able to pretty easily with a distributed generation system, you'll get paid just for being a participant. And in addition to demand response, you've also got revenue that you can generate from selling your electricity back into the market. So say you have a natural gas generator and it costs you $100 a megawatt hour to generate power. Anytime the real-time price in the market exceeds that, you can run your generator, use that parallel switchgear to send power back to the grid, sell it, and make money. So, I mean, what level it's profitable at is going to depend on your fuel type, the fuel price, your generator package, all of that, and your location, of course. But it is a good way to offset that cost of the generator by running to generate revenue. So in addition, you have what's not exactly revenue generation, but instead is cost avoidance. So depending on your location, here in Texas and ERCOT, we have what's called 4 coincident peaks. That means that for the highest single instance or 15-minute interval of power consumption for the entire state in the months of June, July, August, and September, for those what they call 4 coincident peaks, whatever power you're using at that time determines your transmission cost for large enough customers. If you can utilize that generator to reduce your load when you forecast one of those peaks coming, you can avoid your transmission cost in some cases altogether. If not, you can drastically reduce those. So it doesn't generate revenue, but it reduces costs, which in effect is the same thing. Now, we don't expect a commercial business or a municipal utility district to be watching a market to monetize their generator instead of focusing on their core business. So all of this is typically handled by a distributed generation company that monitors these generators 24/7. So they can remotely start them when they need to run for revenue purposes. Additionally, they can see system alarms if there's mechanical problems or know when fuel needs to be filled or coolant needs to be topped off or filters need to be replaced. Really, whatever you need is handled remotely and monitored 24/7. So you've got multiple channels to generate revenue, but additionally, reliability is an issue. A standard backup generator is only going to be running when there's an emergency, a power outage. Distributed generation is going to run for all of the reasons that we mentioned previously for revenue purposes. So what does that mean? For one, an engine that runs more frequently is going to be more reliable. I mean, you can think of your everyday driver versus a car your dad keeps under a tarp in the garage all year. Which one do you think is going to start up on the first try? Secondly, engines just break sometimes. They need fixing. So in the event that something does go wrong, a part malfunctions, a fuse blows, you're more likely to catch it before an emergency if you're actually running intermittently between those emergency events. Now, of course, both types of generators are going to be tested. That's just standard practice for any generator. But an emergency backup only generator, you're going to run the engine weekly, monthly, whatever it may be, but you're usually not going to run under load. And that's because you don't want your facility to experience a power blip, which you have to power the facility to run under load. These distributed generation systems, they can utilize that parallel switchgear we talked about to run under load by exporting to the grid. So you don't have to have a brief power outage that may cause you to have to restart systems at your facility to test them under load. So a generator is a serious capital expenditure, and a distributed generation, it serves as both a way to offset a significant portion of that capital expenditure with a stream of revenue for years to come, and it's a way to ensure you're getting the maximum reliability for that investment. So if you're looking to install a backup generator, I would encourage you to look into a distributed generation solution to see if it's practical for what you need. So if you made it this far, I want to thank you for listening, and I hope you enjoyed learning more about the concept of distributed generation and everything it has to offer. Again, I'm Hayden Gaspard with Acclaim Energy. Tune in a couple weeks, and you can listen to another one of Acclaim Energy's All About Energy podcasts.